So yeah, my name's Dr. Melissa Butt. I'm the chair for World Educational Robotics in the United Kingdom, and I'm the founder of an educational organisation called Discovery STEM Education, which has a big focus on developing the next generation of UK inventors and supporting teachers to incorporate invention into the UK curriculum. This is what I've been working on for almost a decade. But over the last few weeks, on several occasions now, I've been reminded of the amazing experiences that first originally sparked my desire to then want to dedicate the last 10 years to promoting STEM in schools through invention and through robotics. And you'll see that there's a logo up there as well that says Invent Future Global, which is a really exciting new project that we started working on in the UK as well, in collaboration with lots of other countries as well. And one of the inventors that started to remind me of my past has come from an exciting event that we've just done with Invent Future. So about a year ago, I came across this inventor. Some of you may have seen her before. She developed something called the Chemotherapop, which was to help people who were having chemotherapy, something for them to taste, to help them to moisten their mouth when they're having chemotherapy. These are American inventors. Sophie was from Washington, DC, I think. I then saw these young boys who'd invented something again to help people who are having difficulty to walk with a walking stick and to use an umbrella. And shortly after, in the UK, some young inventors started, before they started to use robots in China to help with the gas canisters in hospitals. In the UK, we had these inventors who were starting to think along the lines of doing things to help in hospitals by inventing and using their creativity and problem-solving skills. And then we had our first Invent Future Global global conference a few weeks ago, and there was a really exciting presentation that I got so excited about from a girl from Talcott Mountain Academy, and she designed this glove that you can see on the left hand side, which was to help people who have tremors. And it was really, really amazing. And you probably all realise now that I then started to remember my time as an inventor, and the reason why, you've probably realised, is because all of these inventions that I keep seeing and keep catching my eye recently, they're all medical related. And they started to remind me of my original time as an inventor many years ago. So I'm just going to give you a little bit of an insight into what I did. So there was and there still is a global epidemic of chronic kidney disease. And the thing with chronic kidney disease is that by the time a patient gets to see a doctor, they've already got significant damage in their kidneys. So this is a picture here. I really think it's a beautiful picture. It's a picture of from down a microscope of the histopathology of kidneys. And the one down at the bottom is the healthiest picture. And then going up, they get more unhealthy. And the more blue that you can see, that's the more scarring that there is in the kidneys. And the real problem with kidney disease is that by the time a person has symptoms and they're starting to feel unwell and they go to see a doctor, they're already at the bottom picture. So they've already got quite a lot of scarring. So that's a real issue. And that scarring, it can't be reversed. It can't be taken away. It can be slowed down, but it can't be taken away. So really, my research was to try and invent something like a dipstick, a urinary dipstick test that would be really easy and really cheap, that could be used in countries where they couldn't do other things to help patients who'd got kidney disease, where there's no access to dialysis machines, there's no access to kidney transplants. Something really cheap and easy that you could use, and you could just do urinary dipsticks, stick it in people's urine, and it would change colour if they were starting to develop kidney disease. So in order for that stick to change colour, we were trying to detect some chemical that changed in the urine of patients before they actually got their scarring and before they got any symptoms, so that doctors could do things early to try and help them, especially in countries where there's a real issue with medical support. for things like kidney disease, which is really expensive to try and support kidney patients. So what we did was this kind of experiment, which some sixth formers or young people who are going on to university might recognise or have a little bit of an insight into, or do at some point in the future. This is called a 2D gel, and basically you can run urine from healthy patients and patients who are starting to develop kidney disease and patients who are in the later stages of kidney disease, and you can compare the proteins, because the proteins move down the gel according to their electrical charge. So they move down and they separate according to their electrical charge and their weight. So what you can then do is use some computer analysis to look for spots that increase or decrease in a patient who's starting to develop kidney disease. And we were trying to look for the ones that increased as early as possible before that scarring even happened. So I spent quite a lot of time doing this, and eventually we did find some proteins that did change, that could have been exciting markers that could be used on those dipsticks. And that research is still ongoing now, and it's still happening in universities now. So there were lots of lows and lots of highs involved in my time as an inventor. So the lows that I can think of were sometimes being in the laboratory till 2 a.m. in the morning because my experiment didn't work. And any young inventors who are watching this, I'm sure, can identify and have started to go through that process of trying to do something, trying to make a prototype, testing it, and things just aren't working and it's just not going right. But you just have to keep going on and on and on until finally you get there. So it's just the same when you're being a real trying to do real inventions, and it's the same when you're trying to do medical inventions. There'll be a lot of times when it doesn't work, but then when it finally does work, it's really, really worthwhile. And the real highs of doing my research not only were to actually find a protein that is now still being worked on and hopefully can one day make a difference to people's lives, but I was able to go to places like Athens in Greece and Bergamo in Italy and San Diego Conference Center to present my work in front of lots of important people. So that was really exciting. And that's just the kind of thing that young inventors, if you have a go at doing this now and do a medical invention now, you can also go to these kinds of conferences online and hopefully at some point in person as well. So you can go through all these experiences, but at a much younger age than me. So by the time you get to this stage, you'll be an absolute expert and way better than I was at standing in front of all those people and speaking. So for anyone who is interested in starting a medical invention, what kind of things can you do? How could you start to do that? Especially for I see some really young children who are interested in doing a medical invention, but they have no idea where to start. And teachers might not really have that experience in being able to help and support them to get going. So my advice to you would be, first of all, just speak to people in your family. Who in your family has got any medical problem? So just talk to people, ask people, what problems do you have? How could I help you? What do you need? What kind of thing could really help you? In the UK, a boy did that, and he ended up finding out that there were some people with grip issues in his family, elderly people, and he ended up designing all sorts of tools to help and changing kitchen tools to be able to support disabled people. And he just came up with this great invention just by speaking to people in his family. So talking to people. And then if you can just speak to any medical person and ask them, what problems do they have? What do they find difficult? What problems do they see that patients have? What are the opportunities? What are the opportunities, and where do we need new inventions in the medical world? I think it would be fantastic to see lots more. It's great to see the inventions that young people have been doing so far. And we can see at the moment with the COVID-19 pandemic that there are lots of opportunities and lots of things that are needed to try and solve the many, many problems that we have associated with COVID-19. There's loads of work that young people could be working on with that. But open your mind as well and look at all the other medical problems that there are as well. There's so much that can be done, and it's young people, young inventors with open minds and creativity. You are the people who are going to make a difference and can do great things that will really change the world. Thank you very much.
Dr. Butt, that is First of all, your voice did not disappoint. Just let you know that was amazing. But I know some more about you, that you got your PhD in biology, I believe, and now you're working in robotics. Like, what a turn, and how you're using your passion for medical issues in inspiring kids. Now, did I hear that your students are competing in the World Educational Robotics in China?
Yeah, so they've competed over the last 2 years, and well, we're doing it again this year, but it's online. We've got trials this Saturday in the UK. Schools are doing trials next week, and some STEM organisations are doing their trials this weekend. So yeah, we're still doing that, as well as the Invention as well.
Very cool. And I also read that you might be helping set the science standard educations in your country.
Yeah, so with the World Educational Robotics work that we do, and with the Invention as well, we work very closely with schools, with teachers in schools. We work very closely with one particular school called Sheffield High School, where they have some outstanding teachers in robotics and invention. We also work as part of the UK government STEM strategy group. So that's a steering group that helps the UK to decide where curriculum goes in STEM education. And we work with the Department for Education as well. And we've recently just been awarded, along with several other top universities. We're part of a group together doing robotics, autonomous systems, and we've just been awarded an EPRSC grant to help get that into schools and get that into the curriculum over the next few years.
Nice. So what you're doing is exponential in its outreach, because I also read that you are training hundreds of teachers around the United Kingdom.
So in the last year and a half, we've trained around, I think we're up to 260 something now teachers to teach World Educational Robotics, which is all about problem solving, and it's STEM, it's science, technology, engineering, and mathematics, and it includes so much invention as well. It is robotics, but in order to be able to solve their robotics problems, they're given set problems, but they have to invent various solutions, and no child does it in the same way. So it requires those invention skills as well. Yeah.
And it looks like also that a lot of your kids' inventions are for a purpose. You know, robots are fun, and they're cool to move across the floor and drop a ball into a cup. But you're inspiring kids to do the robotics piece, but with intentional outcomes, especially in the world of medicine. Yeah,
and we've also turned the robotics program into biochemistry problems and invention as well now. So there's a lot of biochemistry. We're actually using the sensors on the robots now to get the children to solve problems, medical problems, using to do chemical assays, to put their test tubes into the robotics kit, and use the sensors and sort of arrange it all in a very different way, to be able to then do chemical assays to detect the colour intensity difference in their test tubes, in their chemistry experiments, which is now starting to come into our invention program as well, because we're starting to see young people who want to invent things that are related to testing medical samples. We've had children talking about testing urine and testing various other things, and thinking about wanting to detect that particular chemical or protein using a chemical dye, and then wanting to find a way to then detect it and invent something new that could be used in medicine and in biochemistry. So the robotics is now kind of merging with the invention program, and there is biochemistry from my background and medical stuff coming in there as well.
That is wonderful. I know you're also on Facebook a lot with your kids and doing Facebook Live. Julie has just suggested that you probably never sleep. She sees you so much. If you could tell us in just a minute, did you see this coming as a kid? What was really, what did you want to do as a kid?
Well, so I started off wanting to be a mermaid, then it went to a ballet dancer, and then an air hostess. And then when I got to secondary school, I saw a really cool movie, which was in America. I don't remember the name of it, but it was one of the first movies that we had about pandemics. And there was a really cool American actress, and I don't remember her name or the name of the movie. And she was looking down microscopes and doing these really cool experiments, and she saved the world. And she then became my role model. And I got really excited about biology, and in particular, biomedical biology, and that's really what inspired me. And I just got into it and loved it more and more and more, and wanted to do as much medical research as possible and take it as far as I could. And then when I got towards the end of it, I realised that what I'd really enjoyed whilst I was doing that was teaching. And I spent a lot of time teaching medics who'd come from Middle Eastern countries to come and learn. They were medical doctors who'd come to do PhDs also on the chronic kidney disease, the same work that I was doing, because in those countries it's such a big issue. If they don't have people don't have a lot of money, then they can't access kidney dialysis or transplant. So a lot of them came over here, and I realised that I really enjoyed teaching them. So then I turned my career to teaching, and absolutely loved inspiring children to take STEM, to take their science, technology and engineering and mathematics as far as they could. And at the same time in the UK, we realised that we got a growing number of jobs coming in the future, STEM jobs, which we really needed to make sure that we fill within the next within the next 20 years. And so there's this big need to really inspire and support young people to get excited about STEM. And so that's how I ended up doing what I do now.
Well, if Renee Russo